Okay, now I'm going to talk about experimental design for a while. And I thought I'd just go through a number of things that you should consider when you're evaluating an experiment to see whether it was conducted rigorously and how much faith you can put in the results of the experiment. First of all, sampling. It's very important that in order to be confident that you can generalize your conclusions, it's very important to perform random sampling of your population. Now, this is, to a greater or lesser extent, difficult to accomplish, especially for graduate students. And very often graduate students writing a dissertation will not randomly sample a population for a variety of reasons. But true experimental design does require random sampling, and the reason for that is if you sample randomly, then you're not introducing any kind of bias into your experiment. And just do a thought experiment right now. Let's say that you asked a group of incarcerated sex offenders to volunteer for a study on the impact of chemical castration. What would likely happen is the people who volunteered for that study would not be the same as the general population of people who were not willing to volunteer for the study. And so that would call into question the results of your experiment. In other words, let's say that you found that chemical castration really did seem to reduce recidivism. Well, it may be that the people who would volunteer for such a study would be more motivated than the population at large that you're trying to generalize back to. So I hope that's clear that random sampling is important, and that is sort of tied in with this next point, which is your sample has to be representative of your population. You can't, for example, say I'm doing a study on child molesters and sample a population of rapists, obviously. That's an obvious example, but in fact there are a lot of mistakes made in this area where people will choose a sample that doesn't really represent the population that they're eventually going to try to generalize their results to. All right, let's see here. Okay, another thing that needs to be considered is response bias. When people are being studied, they very often will be biased in the way they respond based on subtle cues from the experimenter and also their own wish to present themselves in a certain way. And so the best studies figure out ways to avoid response bias, and one of them is to use measures that are not face valid. If you recall my earlier description of face validity, it's harder for response bias to come out when there's no face validity. Another way to control for response bias is to have a blind or a double-blind experiment. Missing data is another important thing that has to be considered. Did people drop out in a systematic way? Let's say that you're doing a study on reducing alcohol use amongst alcoholics, and your intervention is a 12-step group, and at the end of your study, half of the people have dropped out. But all the people who have remained are abstaining from alcohol use. Well, until you feel confident that the people who dropped out did not do so because they started drinking again, you really can't interpret the results of that study in light of the fact that you have all this missing data. And that's a crucial point for consideration. Okay, now sample size. I think we all understand that if your sample is too small, you'll be vulnerable to not finding a significant difference between groups or a significant relationship between variables. leading you to be unable to reject the null hypothesis. So if your sample size is too small, it makes your findings suspect, because there actually might be a significant effect size, a significant difference between the groups or relationship between variables, but you aren't seeing it. Conversely, if your sample size is too large, you may well end up finding a statistically significant difference, but the effect size would be so small as to be practically meaningless. In other words, there's no practical application for knowing that there's a significant difference between groups if the actual difference is so small as to be negligible. So these are things to consider. Okay, next point, parametric tests. If you're reviewing research and the researchers used parametric tests, but they did not meet their assumptions for using those tests. In other words, they used parametric tests, but their data is ordinal. Or they used parametric tests, but their data is not normally distributed. Then those findings are questionable. Operationalization. Operationalization means that the variable that you're actually measuring actually measures what you're saying it measures. And let's just take intelligence, for example. Let's say that I operationalize intelligence as the likelihood of you laughing if I tell a joke. And I define anyone who laughs when I tell a joke as smart, and anyone who doesn't laugh as dull. That's not good operationalization of the underlying latent variable, we call it, the underlying construct. So this is something that you have to really look at the research and ask yourself, did they properly operationalize the issues that they were trying to research? Okay, and then blocking. Blocking means that you account for and remove the effects of a known variable. And let's take, for example, that you want to study whether or not drinking Gatorade makes you run faster. And let's just say that Group A is the Gatorade group, and Group B is the, let's say, the Sprite group. Okay, and let's say that Group A runs significantly faster than Group B. But then, on closer investigation, you find that Group A are all have prior experience running, and Group B are all couch potatoes. Do you see how now what you're doing is you're comparing apples to oranges, and it may not be the drink that they're having that's creating the difference. It may be an underlying difference in your subjects. So, for that example, one thing that the researcher could do is block on prior running experience, so that if a person answers a questionnaire, you say, do you run 3 or more miles per week for the last year? Have you run 3 or more miles per week for the last year? If the answer is yes, half of you go in Group A and half go in Group B, and no, same thing. That way you're controlling for the impact of prior experience. Of course, it's impossible to block for every variable. And it's just, I think what people need to do is they really need to think about their subjects and ask themselves, is there anything that obviously we should be blocking for in this study?